Good morning. Welcome at the CPS Verity seminar. Today's speaker is Tomáš Telenský, and I will just briefly introduce him. He's a new postdoc at CTS. Tomáš studied mathematics and physics originally, but he was always keen on birds and nature in general. So he did his PhD later on in the Institute of Environmental Studies in the Faculty of Science, and he was dealing with several issues concerning bird population dynamics. He will speak about population changes, but I would stress now that his very important achievement was publication of this big book. He's one of the 4 authors, but he was responsible for all the basically calculations concerning the distribution of bird breeding bird distribution in the Czech Republic. I can recommend, actually there are several books of this kind, so we have very good knowledge about the changes of the distribution of all birds in the Czech Republic, which is quite unique. But this new atlas is really new in this, in the sense that there are some not like besides the pure data, there are some calculations concerning the effects of environment for the distribution and so on. So it's really a big kind of update of what we know, and this update is what actually what was Tomáš's achievement. So please go ahead.
Thank you, David, for beautiful introduction. Yeah, I'm grateful for this opportunity to have this presentation here. I don't. This is not working.
No, you usually hit the slide and now it's working.
Oh, okay. So I would like to basically present a mosaic of my research. And we will be going towards the population dynamics. And to introduce it to you, I will present it on a very nice story of long-distance migrants, which was basically also one of my biggest motivations for this. And then we will move to something which is more methodological, because I'm, as David said, I'm coming from mathematical and physical background from maths, and so when I came to ecology, I wanted to use my ability, so I was focusing on the improvement on methodologies. I'm actually the guy who most often, like when I read a paper, normal people just read abstract and maybe results. I'm just reading methods, and I say, hey, David, I saw some interesting paper, and David's like, oh, so what are the results? What are the conclusions? I don't know. Some cool method, like using Gaussian process or something. So these topics will be more methodological, but I will try to present them in a very simple way, and also, yeah, you will come to it. And then I will present a lunch a little bit, because we are going to a very special place that needs some introduction. So this, I would like you to give you general introduction, which is not part of my research, but just to give you some simple background. Population sizes, I think it's the most important parameter in ecology. It's important because we want to know how the species are doing, especially in the recent time period where the human pressure is strong. So we use this information also for conservation purposes, and maybe some list of vulnerable species. And it's crucial to be able to explain the factors that are behind the population changes. So there have been lots of publications on this. And the birds have a special position in this ecology, mostly because they are very popular. There are so many volunteer ornithologists that are willing to collect data of super high quality. For example, in Czech Republic, we have like hundreds of people who are collecting very standardized data, standardized protocol since beginning of 80s. So we have actually 40 years of time series, which is pretty amazing. And you cannot say that for other taxa, for other groups like butterflies or amphibians or this. So birds basically have the best data coverage, like across the whole continents, America, Europe, and they are accepted as a general indicators of the biodiversity. For example, the common bird indicators published by Peckel's group, which is actually based in Czech Republic, Czech Society for Ornithology, is coordinating this. I can present it on this plot. So here we have the time scale, and here is the population index of species. So if we take all common birds, they are slightly declining across the whole time period, and forest birds were first declining, then now we see a slight recovery, and there is a huge decline of farmland birds across Europe. This is from the whole Europe. This pattern is this is a general pattern. This is farmland birds are suffering everywhere almost. But
What's the reason why farmland birds
because of
disappear?
the intensification of the agriculture. It's that there is more chemistry used, like there is less insects, and then there is this
Homogenization of landscape.
Yeah, thank you. And that's different in every country, but this trend is like very general.
Can I ask, would the same picture be for like maybe to just the Czech Republic? Because
there's very strong decline of farmland birds in Czech Republic as well.
Still since the 1980s.
Yeah,
because,
yeah.
Most of the large fields were created already before.
Yeah, exactly.
There must be something different.
Exactly.
No, but it's
like
not-
structures,
it's
farms, and
Yeah, I think there was some strong. I don't have the graph right now, but there was also some strong increase of the decline after the revolution because there was more chemistry and more intensification based on the economic growth as well. So, and
No, but it's no, it was less.
Less?
Yeah.
in the beginning,
much less.
and
Fertilization.
Yeah.
because it was so expensive in the beginning, and like later they got subsidies from EU, and they started to buy more.
Yeah, exactly. Sorry, I forgot that after revolution there was a
10 years.
period that some who were doing good. So I think that Petr Božižek was joking that revolutions are good for birds.
And for butterflies.
Also for primates.
Yeah. So this was just the introduction, and this data are actually collected and processed in Czech Republic in Society for Ornithology. And these indices that I'm showing you were accepted actually by European Union as the indicators of structural indicators and sustainable development indicators. So the data are actually used in policymakers and also by other agencies. So yeah, farmland birds decline, and then there are like strong patterns regarding climate, which we will focus on the impact of climate on birds. So in general, both positive species decline and both positive species increase. Like we can see from this paper in Europe, the population is going down. The both positive species, and in America the pattern is different, but in general the cold positive species are doing worse than the warm positive. And this means like the species that have diminished more towards the colder temperatures, higher elevations, in more northern latitudes. In general, species ranges are shifting north or upwards, like elevation wise, but the shift is not fast enough to track the climate. So for example, from this study, they found that birds were shifting 37 kilometers north, or on average, butterflies 114 kilometers, but the climate was shifting 249 kilometers across this time period in Europe. So we see that it's, there is a clear impact of global warming or climate change, but the organisms are not coping fast enough. So it's very important to focus on the impact of climate change in birds. And actually, the long distance migratory birds are doing the worst. They decline or they have worse trends than the other group. Not everywhere, but so here I want to focus on them.
Sorry, there is a question in the audience.
Yeah.
Just when you are showing these like two population like trends like with the permanent and like woodland birds and then like warm and cold, did anybody look at like interaction between these two? Because in general, like in normal landscape anywhere, like the farmland areas are typically the warmer ones.
Yeah. So they should be increasing, but they are.
Yeah, so it could be like partly like buffering the climatic effect.
Yeah, I think almost. But like a lot of studies did, I think even David has had presentation 2 years ago about different like patterns in the population trends, and also including this. But
these are relatively independent patterns, and farmland birds are declining, and warm, I would say one positive is are increasing, and both of these patterns are there actually quite strong.
Now the story of long distance migrants. I don't know if I want to explain. So yeah, I want to explain what is long distance migrant. It's sorry, I will skip here. So here we have the map. And we are talking about species that breed in Europe. So they in the spring they produce young birds in Europe. And the long distance migrants are those who are spending their winter in the sub-Saharan Africa. So they migrate over the Sahara. They make this amazing journey, and they come back next year. So this we call long distance migrants. Short distance migrants are those that breed, let's say, in Czech Republic, but they are wintering north of the Sahara, so Northern Africa or Mediterranean, typically, or Southern Europe. And residents are those that are staying over winter, more or less. There are some partial migrants that, but basically that's the main classification. So just to know what we are talking about, this long distance migrants and climate, I will be presenting what we are publishing 3 years ago with Jiří Rajv. It was part of my dissertation, and here I am showing that actually this is the motivation for why to look at long distance migrants. If we look at the trend in Czech Republic from ranking data since 2004, the long distance migrants are actually doing the worst. This is the trend. So 1 means there was no change in the population size, above 1 is increase, below is decline. And this is the best estimate of the parameter, and this is 95 confidence interval, which means that the true value should, according to the model, lie within this interval. So we see that long distance migrants almost significantly decline, and they are doing much worse than short distance or residents, and the residents actually increase. So this is actually a beautiful result. Like there's not many times that you have some hypothesis and you get this beautiful result, and it shows that these are doing the worst. And the question is why? So for this, we are looking at the life cycle, and we can see what is happening in different parts of the life cycle. There they have to bring up young birds, and then they have to go to Africa and they spend winter here, and then they have to survive the winter and also the migration. So most of the studies are looking just at the population sizes, but here we want to focus on these different parts of the life cycle separately, and for this, actually the demography comes into play. Okay, so we can separate the breeding productivity. If we have data to study breeding productivity, we can study breeding productivity separately and survival also separately, and look at the impact of the climate on both parameters. And there are actually hypotheses that are related to what is happening to long-distance migrants. And that's the most famous one is Tropic mismatch hypothesis. So let's say that this is the time axis during the year. So here is I say like March, April, May, and here is the time window of when the long-distance migrants breed. And this is the abundance of their food, in this case caterpillars. So let's say like the springs are becoming warmer and warmer. So both processes will shift, like become earlier, but the caterpillars are shifting faster in general. And the long distance migrants are known for having a very low flexibility in adjusting this phenology. Phenology means the timing of the breeding. Well, they have less flexibility. The limit is in the arrival. They have very low flexibility of arriving earlier. They have little more flexibility of just like there were some studies on this, that they can adjust the start of the breeding by shortening the period between arriving and starting to breed. So they are trying to compensate by this, but they don't have much more options with the arrival because of conditions in Africa and stuff like that. There is like opposite selection there, and so they are much less flexible with the timing than resident birds, for example. So when they reach their limit and the spring continues to be warming up, the food can actually, the peak of the food can actually come even earlier than they start breeding, so they have less food for the chicks. So this is a strong pressure, and this is why they, according to this hypothesis, are most sensitive to the climate change. And that was published for many like trophic levels. This is like trophic levels, potravní žebříček in Czech, birds and caterpillars. And this mismatch was shown for different like trophic levels in different taxa. But in general, it's like if you look at the pyramid, and the pyramid stands on the climate, then the climate is shifting the fastest, and the lower levels are adapting faster than the higher levels. Basically, that's the general pattern. It's not always, there are exceptions, but it's like that. So this hypothesis is saying that warmer springs would result in lower breeding productivity of long-distance migrants.
And what does this mean to them? Does it mean that they move from, let's say, Czech Republic to Italy, or they just disappear?
No, they are actually very conservative. Long-distance migrants are very conservative of their breeding side, which is counterintuitive because you say they migrate for such a long distance, so they could choose Italy because they are crossing it, but actually not. They are they will come to the very same nesting place, like. And for example, Swift tables breed on the same building in the same hole, and they are if there is a reconstruction of the building, they are just confused and they are looking for a hole, but they are not using it that year. They will just be checking it and they will not bring it that year. So they will come next year. They are very conservative.
Very nostalgic.
No, it's actually pragmatic because they need to know the temperature.
Yeah.
Because if they hatch the chicks, and then like 1 month later there is like 50 degrees or something, and they will die. So it's actually there is actually good reason behind it. But okay, let's come back to this. So higher temperatures would result in lower breeding productivity in long-distance migrants. And then there is another hypothesis in what is happening in sub-Saharan Africa. Actually, this is the index of Sahel rainfall index. The Sahel is the stripe just below the Sahara, so the driest part south of the Sahara. And there were some very strong droughts in 70s and 80s. And already there have been observations that these birds, the long-distance migrants, white-throat and sedge warbler, have experienced very strong declines in that time period. So this hypothesis is saying that the water availability should positively affect survival and vice versa. The drought should cause like lower survival over winter. So just to explain the survival and these parameters in a mathematical way, very simply, let's say this is population size in the year I, and this is population size in the next year. And population growth, if we say population growth, we mean in the multiplicative parameters. So if it's 1, it's stable. And then if you look into more detail, so the population in the next year, population size in the next year is the population in the previous year times the survival rate. So this is the number of individuals that survived from the previous year. And this is the number of new individuals, and that's like population size in the previous year times productivity. So this, if you look at this, that's the number of young birds produced during the breeding season. But these young birds, they also have to go to Africa and survive the whole journey. So that's the survival rate of the juvenile birds. So yeah, so this is survival for adult birds. Sorry, I forgot to say that this is the adult population size. And this equation is for the birds that will become adults after first year. So this is the simplest model. So this is breeding productivity, this is juvenile survival, and if we multiply these two, we get recruitment. And actually, here from the ringing data that I will explain in a while, we can estimate adult survival, we can estimate breeding productivity, but we cannot estimate juvenile survival because the birds have very low site philopatry. They don't return to the site where they were breeding, so it's almost impossible to catch the juvenile next year because we would have to catch all the birds in Czech Republic or something. It's impossible. But we can estimate the recruitment, which is product of these two. It's actually not easy to calculate this one because there is some technical issues around this. So we cannot simply estimate this one at the moment. And this is also called like Leslie matrix. You can talk about Leslie matrix, which is containing these parameters. And so this is the basic of population dynamics, this equation.
How many percent usually died during the journey to Africa? Is this more than 10%? Yeah, I mean those small birds.
The survival is. We will actually see. I will show you. That's a good question. When we will see some results, I will show you. So this is just the scheme. So this is the population growth. This is the main parameter that's saying how much the population is changing. To this is contributing the recruitment, which is recruitment means the rate of new individuals entering the population already after the juveniles, after the spending winter in Africa. To this contributes the breeding productivity, and that's affected. That is supposed, this is hypothesis, supposed to be negatively affected by spring temperature, and the survival is supposed to be positively affected by water availability. And there is also carryover effect that which is like the hypothesis that if there is enough water, it's good food in Africa, the birds can have good fitness, and when they arrive to breeding sites, they will be having higher productivity. So yeah, so we are actually looking at these relationships right now. And for this, we use the data of constant effort sites scheme in Czech Republic. This is a scheme of bird ringing. So birds are captured in these mist nets, and they are ringed. And if we catch them another time, we will report the occurrence. The most important aspect of this is that it's very standardized support. So the people cannot just do it as they prefer every year differently. They have to keep constant length of the nets and constant placement. And it's based on volunteers, because there are enough enthusiastic ornithologists that are even willing to follow this very rigid and very demanding protocol, which is like 9 visits or during the breeding season. This is really a lot of work from May to July. And in Czech Republic, it's running since 2004, and we have like 50 sites across Czech Republic. This is not complicated.
Maybe I have a stupid question, because I'm not even amateur ornithologist, but if the birds are the same, and probably this is an unpleasant experience for them, don't they learn to avoid this particular space? So actually,
this is a very good question, and this is called trap response, and it has actually been researched, and there are like discussions about this, and there are some advanced models that are able to deal with it. But I have not been focusing on this, and the reviewers are not.
So there's like a coefficient that you can just multiply your return ratio, and then you will get the survival more precisely, right? I don't know, like,
but you don't know the coefficient. So
okay, but like, for example, you could, there are ways how to estimate it, right? Like if you change the place only slightly, so it's like the same environment, same site, but suddenly it's somewhere else, and compare it to the scenario where it is at the exactly identical place, you will get some idea like what is.
Yes, you are right, but I don't think that the problem is with the place, but with just avoiding the net.
Yeah,
right.
they are going.
They will notice it.
Yes.
They can.
Okay. Okay.
Yes, and so it's not the problem is not that much with the placement, but with the fact that
they see it.
They see it.
So why did they bump into it in the first place? They were just curious. Wow. Well, let's throw myself on this object.
It's important. I was also helping in this. I don't have the ringing license, but I was helping. And I remember that it's important that there is vegetation here, and that makes a big difference. If you place it in the middle of nowhere, it will not. But if it's in the middle of vegetation, they are just not paying attention too much. But
I want to be in this bush.
Some birds are even very obvious. So it depends, Normally, mostly they don't see it, or they behave like they don't see it.
Actually, even people sometimes do not.
You will be so clever.
Even people on bicycle.
I was just wondering about this citizen science program. Who is actually organizing the volunteers, and is anybody checking if the volunteers are really following the protocol? Yes. Because I have I have experience with some like other like citizen science programs like in botany and actually in astronomy, and I always had the impression that like it's like for people like without quantitative background, it's like real like a tremendous problem to convince them that like we don't need the data that are perfect, we need the data with standardized error, like
Yeah. There is actually no one standing behind the people but there is a lot of motivation going on. Like it's organized by
Czech ringing center.
how to say it?
Ringing center.
Ringing
Czech
center.
ringing
Yeah,
center.
Czech ringing center. And there they have like a lot of meetings about why it's important to keep the methodology. I was also contributing to that and writing some articles. And they have to get the license, you need to go through kind of like
This is a whole several-day course,
Yeah,
and it is
yeah.
really highly standardized. Just keep in mind.
It's real like people like seem convinced that like the standardization is important.
Yes, of course. Keep in mind that the ringing birds is one of the oldest like citizen science. You know, it's really 100 years. Also, there was a big progress in understanding these, and all these collaborators are in close contact to the head of the ringing center, who is Jarda Cepak, our friend, and they are coordinating it very, very in very like nice details. So I in this respect I would not have any kind of problems with it.
Can I add something? Just a curiosity regarding birds falling again in the trap. I think it also depends on the family, because as far as I've heard, corvids fall once and they don't fall in.
And they tell each other.
Yeah. Doing mismatching with bats, and with bats actually you cannot repeat the same site very frequently because they do learn it. So you have to go changing, which makes the standardization more difficult because you cannot go many times to the same place.
Yeah. There are some models that are able to deal with this, but they need more detailed data, and
But
there are different ways to
by the way, like the personal experience is that I was always surprised how kind of stupid some birds are, that they can repeatedly go to the same nest, you know, again and again. So apparently, you know, they do not kind of
Within the same day, like the same bird has fallen the same day.
Yeah.
So maybe it's a sadomaso bird.
Maybe evolution doesn't work.
Also, I can imagine that this is something that might have like influenced the first few years of like of the survey, that like actually you would get more birds, but if you are running the same place for 30 years, I mean, it doesn't matter like whether the birds had like 20 years to learn it or 10 years to learn it. That there was like
yes, but the birds mostly live like up to 2 years.
Yeah, that's why,
there are different ways also how to parameterize this effect. You can have like some different curves, or you can say like, okay, the trap response will work just right after first catch, and there are different ways how to do this. So, but I haven't given it to the priority, I think, in this year. Okay, so and the half of the locations are in some more wet habitat like reeds, and half of it is generally more drier habitats. So from this data, we are able to calculate the demographics, not only the population sizes, but the breeding productivity, the survival, recruitment. The survival and recruitment is from the capture history. So you have like the whole track of one individual. You have like been captured in the year 2004 3 times, then 2005 nothing, 2006 have been captured 1 time. And from this type of data, using very smart models, you can calculate the demographic parameters. This is not so important. We have some climate variables, basically. I've chosen evapotranspiration in Africa, and some different ways how to express temperature, but that's just a detail. But important is that we split this is the wintering ranges in Africa. we don't have very good data because there is not much data from Africa, but just from these Czechoslovak migration atlas and from other information, we basically compiled this information on different species per different winter. And the yellow part is the part of the region that belongs to the Sahel areas. Because the Sahel area is the driest area just below the Sahara, we had the hypothesis that the effect of water availability will be the strongest in this part. So that's why we split the region in these two, the yellow and blue areas. So we basically did like some statistical analysis.
Sorry, can you just show the? I'm just wondering. So these are the ranges only for Czech and Slovak birds, right? Not for.
Yeah.
Because I'm just surprised because, for example, Tropic migrate to Southern Africa regularly, but probably not from our region.
Yeah. This is for Czech birds.
Which is interesting because they are so common in Southern Africa, but so probably they are from Scandinavia or somewhere.
Yeah.
Okay. So you explicitly focus on the wintering ranges for our
yes
populations.
This whole paper, this whole study was done for the Czech birds. And just this is you can look at this atlas. For some species, there are like 3 captures in Africa, so there is not much data to base this on. But they also like used when they were compiling this. This is their classification. They were classifying the regions in several areas and also looking at literature and combining this together. So we related the productivity to climate, and we also introduced the effect of density, which is very strong in breeding productivity, just to take care of this. And the survival we calculated with Cormack-Jolly-Siever model in the program MARC, and we were accounting for transients, and transients are birds who are not contributing to the local populations. They are not breeding. They are not creating the population dynamics that we are studying. They are just making mess in the data. They will just pass through your nets, and they will never appear again. So if you don't account for this, you would think that the survival is very low because the birds are just disappearing. But it's just because of those birds that are passing through your sites, and it could be birds that migrate north still, or it can be birds who are not breeding. Just they are local, but they are not breeding. So it's important to take care of this, and then we are relating the survival to the climate according to the hypothesis that I presented. And the results is actually beautiful confirmation of the hypothesis that this is the response, the regression slope of the productivity to spring temperature. So 0 means that there was no effect, and positive value means that there was positive effect of temperature on spring temperature, and the negative values mean negative effect of temperature, and that actually confirms what we were assuming, that long distance migrants have a lower breeding productivity in the warmer springs. And here I show the comparison with the other migratory strategies, the birds that winter in Mediterranean or that stay over winter, and you can see actually there is positive effect of temperature, which is very intuitive because as I've shown this mismatch, they actually can start breeding earlier, and they are tracking the phenology of the food because they can start breeding earlier. So they can even take advantage of the warmer springs because there is more food. They can make more breeding attempts, some species breeding more times per year. So they thrive on warmer springs, but these don't. These are have very low flexibility to adjust to the climate change, which is very, this is very important result for the conservation, because we know we are talking about the impact of like the anthropogenic climate change and how it affects different taxa. So we see that the migratory birds are the most vulnerable, and because of this. Here's some more detailed results. There was like 29% of the variability of the productivity explained by the spring temperature. And if we look at what is happening in Africa, we actually observe positive effect of water availability in the sub-Saharan Africa, and the strongest effect is again in the Sahel part, as we were assuming in the most driest part. When you have a little bit more water, it makes a big difference. And there is 18% of explained variability in that. And also it's beautiful to look at different species, how they were doing. So this is the bold values are where the water was having a significant effect on the survival. And we actually saw significant relationships on the species level for the sedge warbler and the white-throat, which are exactly those two species, as I showed before, that the British reported in 70s that they were declining due to Sahel droughts. So this is also like beautiful confirmation of the patterns that were observed earlier by British. And in the part of the wintering region in Africa that is south of the Sahel, that there were different species, because every species is spending winter in different places. But if we average over all species, all long distance migrants, we get exactly this result that in average the water is having a positive impact, and the droughts have negative impact. This climate change can result in droughts in Sahel, and also there are other problems like there are these beautiful movies and books about what is happening, how they are using the trees for the cattle, and there is like decline of trees. On the other side, there is like the green belts activities and stuff like that. So
it seems so far it seems that you basically did not kind of distinguish these effects of spring temperature in our region and in Africa, because both of them have the effects. So, but these effects probably are different for different species, right? For some species,
you mean temperature in Africa?
Well, water in Africa, but you know, I thought in the beginning that you wanted to kind of distinguish whether the climate change affect the bird population dynamics due to what is happening here, spring temperature, or what is happening in Africa. Mm-hmm. And now I was saying that both these effects are there.
Yeah.
Okay.
Exactly. Yeah. Both effects are there, and we can look at. If you look at here, we just see that this effect is. There is a little bit more explained variability than here. Yes, so they both take place. This has like slightly stronger evidence.
But this is for all birds, right? So
no, this is for the long distance migrants.
Yes, for all long distance migrants. But this percentage should differ among different species, right?
Yes.
And that would be more interesting than the overall effect, because isn't it?
Yeah, we have similar table, and for here I present the species level result. We have also similar table for productivity effect, but we did not.
Well,
we did not consider it interesting. We considered more interesting the general patterns.
Yes, but if the general patterns is that everything plays a role, it is not that interesting, right? Because it would be interesting if you found that one effect is much stronger, and it's not much stronger, or it is stronger but not that much. So for me, it would be more interesting to distinguish what is really the crucial effect.
Yeah, the problem is that we cannot this methodology that we used was not allowing us to rigorously tell which effect is stronger. And it's because different reasons. For example, as we saw these ranges, we have very imprecise idea where exactly the birds are. So we are actually taking the water availability in these whole regions. We are averaging all these whole regions. Whereas in Czech Republic, we were doing it very precisely based on every location of every place. So the precision in Africa is lower, and also the survival is a little bit more maybe difficult to estimate than the breeding productivity. So if we look at this, then this percentage also can reflect that we have better data, and we didn't find, and this is very good. This is actually very good for some future study to compare these two effects. And I will come to this when we will look at the population dynamics. But in this study, we were not able to compare. And the carryover effect was quite weak. It's not such a strong relationship between fueling with food in Africa and then breeding productivity, according to the expectations. But there was some effect there also. Some improvement in breeding productivity than there was enough water in Africa. So we basically confirmed both hypotheses, and the mismatch hypothesis was supported a little bit more strongly than the Saharas. And the long distance migrants are most sensitive among the species groups. So at this point, that was the first topic. So we can have discussion, and maybe you can unpack this. If there are some questions, if you know how to do.
Just click on this. Yes.
If there are any questions,
I have one question. So one of the hypotheses we're testing was the tropic mismatch because of arrival date. Did you also look at the arrival dates of the long distance migrants? Okay.
That's also, some studies are doing it, and they actually are testing the mismatch itself. We were testing the consequences of mismatch. So we cannot rigorously say we prove the mismatch. We can just say that the results are supporting the mismatch hypothesis, but we don't know. Yeah, but it's very likely the mismatch.
Yeah.
But that's also very good for another study. Very good topic.
Thank you.
So if there are no questions, we are moving on to the next point, and that's the population dynamics. So this was an introduction why it's important to look at the demography and what it can bring for long distance migrants. And we were studying actually these relationships, but I was thinking that it would be nice to also know that we have population growth. How much is it affected by recruitment of new individuals, and how much is affected by survival? So just to understand the rest of the picture, that's the motivation for the study of population dynamics. So again, just a reminder, the population growth is the ratio of the population the next year divided by population this year. This is the number of adults, so it's like population growth of the adult population. And this population growth we can decompose into the survival rate, the birds that are from the previous year, survivors, seniors, we call seniors as well, because they, that they have been already adults in the previous year, so these are seniors. And this is the rate of the new individuals coming to population. So for this, actually, there already exists Prado model from 1996. This model has been used so many times. It's more than 500 citations of Web of Science. It has been used for so many different taxa, birds, amphibians, mammals, lizards, everything. But this model actually had a very limiting limit that it cannot handle the transient individuals, as I explained before. And many papers are actually commenting on it. Oh, we have some transient in the data and this model cannot handle it. So there is possible bias, blah, blah, blah. So I was thinking, because I'm the mathematical guy, yeah, I have to improve this. I have to make new model because I was so passionate in making new models. So I was working like more than 2 years on that improvement of this model, that it can handle the transient individuals. After making many mistakes, I actually found the solution, and it's currently under review in Methods in Ecology and Evolution. So I hope it will go. Sorry, I didn't say that this study was done with David and Jiří. Yeah, so that's basically we submitted the paper about this model. So my work on this was basically methodological, developing a model that's able to do this analysis. And now I will present results that are not just maybe preliminary. I don't have like some conclusions yet, but it's there is very good potential for research. Just to show you that the effect of transience is not negligible, and it could have made problems in the previous studies. That if you look at this species, garden warbler painted Bavíková, and we look at the percentage of resident birds. So birds are either transients or residents. So the percentage of resident birds is declining, so the percentage of transient birds is increasing. And that's in the dry habitats. So there is decline of resident birds in dry habitats, but increase in wet habitats. And interestingly, the same pattern was in the population size of the residents. So, and I found in literature that is usually correlated, that the population is declining, there is more transient birds and there are less resident birds. And it could be because there is more food in here, and due to some maybe droughts. It's better productivity in these type of habitats.
You are saying, okay, this is the proportion of residents.
Yeah.
But you are saying that the same holds for total like population.
Yeah. For
Okay,
the resident
okay.
population size, which
Okay.
is not visible from this.
Okay. So they are basically moving from dry to wet habitats
it
during
looks like,
last
exactly.
15 years.
Exactly.
Okay.
So we can also study the effect of transients. And there is also a pattern which I'm not showing, but that in wet habitats for many species, it depends from species to species, but sometimes the percentage of resident birds differ between the habitats, and the wet habitats are many times used for the birds that are just passing through because they are fueling for the migration. So it's also important to include the transient effect and study it in different habitats, or at least to include it in the model so that your data are not biased by different transient rate in different habitats. And we actually invented a beautiful way how to visualize the results of the model. So the model, the purpose of the model is to decompose the population growth into survival and recruitment. And the population growth is the sum of those two parameters. So we actually have three things that we want to visualize. So that would be like 3-dimensional graph. But because it's a sum, we can make it in 2 dimensions. And population growth is vertical axis, and then we have these two, and survival and recruitment. And you remember like from school, like the vector, summing the vectors. So these two vectors are summing into this vector. So we have actually a graph that has 3 axes.
Is it animated?
Sorry?
Is it animated?
No, no.
Like it's 4 dimensions.
I will
No,
ask you for making better.
No, show us the results. I'm curious.
So also, if you look at this axis, the position, there is 0 and there is 1 here. So if survival is 1 and the recruitment is 0, the population growth is 0. Like this is the horizontal line means the same level of population growth. And
So it's not like summing the vector, it's something slightly different.
no, it's summing the vector.
Because I think when you sum the vectors, then they sum like you need to do perpendicular.
It's with 0.
Okay, and I
This-
understand.
this
This is not the sum.
one,
I know this is the position of
Yeah,
1. Okay, of course. Sorry.
Yeah.
Sorry.
Yeah. So this position, how to say, different level of horizontal position, this different level of population growth, that's constant for this. The constant survival will be like this, constant recruitment like this. And if you look at the tilt, this is 1 year, okay? So in this year, the survival was like this, the recruitment was like this, and the population growth is like this. And if we look at the position, like polar axis, like if we connect this point and we look at this angle, and the point is here, that means that there is only recruitment playing a role in population growth, and the more is tilted to the left, there is more survival in the population, the more proportion of survival in the population growth. So this parameter is called seniority. If the point is more to this side, there is more proportion of the surviving birds in the population. But general pattern is that the long living species, like people, they will have higher values of seniority, whereas the birds that are just very fast on the fast continuum, like they have a lot of chicks and they have shorter lives, they will be more on this good side of the graph.
By the way, does it mean, I was always wondering that this definition of these terms depend on the temporal scale or temporal step, right? Because here you normally assume the temporal step of 1 year. So you basically, the seniority means the proportion of individuals who survived from the previous year, right? But if the time step would be 10 years, right, it would change the definition of these variables. Is it true?
There will be no survival in that case. So
Well, no, not for birds, but for people, yes. So you can even kind of change the time step to the generation time. Right, so because normally, of course, the time step is 1 year. So how many individuals were still there 1 year ago, and this is seniority, and the proportion, the other the other side is the proportion of individuals who were not here the last year. But you can do it for any time step, right?
Yeah.
Potentially.
I haven't been thinking about this, but yeah.
No, I just
compare.
Yeah, I just wanted to point out that it is relative. Yeah, that it is all relative to the time step. The definition of what it is not like you cannot say like or you can say, okay, what is the seniority of the species? Which is very useful, very useful parameter, but it is always given by the time resolution.
This is a very good comment, because for the birds, it makes most sense to use year as a unit, because they have very specific like breeding seasons, and the year is actually the most natural unit. But people they are breeding all year round, right? And we've been actually citing one paper that used the rodents, mice, and they have completely different types of reproduction. So in that paper, they used a day as the unit next week, and convert or months, sorry. And we have to convert the survival rates and all the population dynamics, we have to convert to the scale of years, so we have comparison with
No,
birds.
that's the point, that if you use the 1 year for mice, you would have zero seniority
exactly.
by definition,
Yeah.
right? So,
Okay, so here I have, don't look at this, this is not here. So here we have the results. Actually, we call this talon plot in Czech graph because of the shape of the axis.
Talon, does it have any connection with talon in marriage?
No.
Are you sure?
Yeah, I'm sure, because this,
we don't know talon in Maria at all.
Yeah, there are 32 cards, and when 3 people are playing, they all need to have the same card. So one who is playing alone has 2 more cards and says, I don't want these 2 cards, and puts them in talon, which might mean that like under some hand like this.
I can say that when I was inviting, when I was trying to invent this name, I was never thinking about mariage.
No, so you invented the name.
Yeah.
Also, you can tell what is the origin of the.
Yeah.
But
Okay.
the point is that, so does it mean that in mariage they took it from the word talon? Because
I don't know what it means. I think it's from Latin.
Talon, it's, I think in most Latin languages, it's like a heel.
Heel.
Yeah, in Spanish.
Under a heel, I will need them. I will put them in.
Well, actually,
Heel, yeah, that's.
actually, this, if you have better proposal for this, I'm.
No, this is nice. I like it.
Because pařád in Czech, pařád in Czech is clear. This is pařád, but in India, translate pařád to English was impossible. Talon actually means, I think it means different part of the, or it means different part of the food than this. So, but there was no proper word in English, so I was choosing this just because I didn't find any better.
Okay.
So there is actually results for Great State, Sikora Konyadra, and so here we have the talon plot, and the black points are different years, and I'm actually enthusiastic about this graph. I think it contains like the whole population dynamics. For example, if you want to look at the year with the lowest population growth, the year when the population was declining the most, or maybe these 2 years. So the population growth was almost the lowest, and you can actually read why. You can look here and you think, oh, so the survival was at the lowest level. The recruitment was kind of average, and here was a little bit higher, but the survival was also in those 2 years it was due to low survival. So it actually tells you much more detail than if you just look at the population sizes of the changes.
This is perfect, but I would somehow like color coded the years so you can see how these things are autocorrelated or not. You know, like
yeah, I see.
this is what I meant with the animation, because you would see like how this changes, how it tracks, what trajectory does it tracks through the plot, or you can do it with color or something like that.
Interesting. Yeah. Interesting. Just to make some path through this space of
because there is like almost a clear cluster of super successful year, but it's super successful because of huge recruitments. And it would be interesting whether these are like 3 consecutive years or whether this is just, I don't know, like warm spring or something like that.
Yeah, it's because of density dependence, all the populations are density regulated.
Yes.
So usually when you have a good year, it's more likely that it will next be followed by a little low population growth, because the density,
the population density is huge.
Yeah,
Yes,
yeah.
exactly. But it would be really interesting to see.
So this so this is for native, and I also chose the result for different species. Rákosník obecný, reed warbler, and the reason why I choose those 2 species is the difference in the correlation between survival and recruitment. this species was the one that had most negative correlation of these parameters. So the points are spread more horizontally than here, and here they are spread more vertically, which is like positive correlation of these two parameters. And the reason why we are looking at this, so we can look at different years, like and look at what's happening in different years, but the general patterns, how these points are correlated, how they are, the whole cloud, how is the whole cloud like situated, is very interesting as well. Because what can we say in the case of great tip? They are negatively correlated. You can like imagine that the cloud is more horizontally spread, just to have it like didactically. Then the years where the survival was the highest are the years where the recruitment was the lowest. So we can assume, we have only correlation here, but we can assume causality, or there is a much more likely that the surviving adults are limiting the number of recruits that can enter the population. So if there are a lot of surviving birds, that there is not too much space for new recruits to come. Whereas if you have years with the low survival, there's more space, more possibilities for the recruits. So that's the scenario where it's regulated like this. Whereas in this scenario, there is no such regulation based on this. And in this scenario, both survival and recruitment vary together during years. So it means that there are some common factors that are driving both demographic parameters, and it could be just the density itself. Yeah. There is density-dependent survival and density-dependent recruitment, or it could be in this long-distance migrant, but it could be also the climate in Africa, which is affecting the survival. Yeah. But it can also affect the recruitment through the survival of the juvenile birds.
Or it can just mean that the population is very far from the carrying capacity of the environment.
Yeah, yeah.
So yeah. You know, okay.
So this is beautiful because this shows different ways how the population can be density regulated. In this case, the regulation is taking place immediately. That in the extreme case, when the cloud would be like spread like that, that would be very strong negative correlation. There would be almost no variation in population growth. The population growth would be almost the same. It would stay almost constant, but there would be different recruitment and survival during the period. And this is happening. We don't know yet, but we have the hypothesis that this could be because this species is breeding in the cavities or nest boxes, and the limit of cavities is one of the strongest limits. There are studies that show that if you hang nest boxes, it like improves so much the productivity of the bird. So there is a strong limit on the number of breeding birds that is given by some external factor like this, which is not in the case of this bird, which is making nest in somewhere in the reflex and is more flexible to for the population breeding population size.
But actually, here it is important what actually Peter asked, because it's possible that actually the population is very strongly regulated, and you know there would be an argument that it is not the case that they are far away from the carrying capacity, because you can see that about half of the points are above 1 and half below 1, which can, you know, so it is around 1, so they are not expected to be far away from the carrying capacity, and you can imagine that in fact, and now the time series would be interesting, that every single dot which is above 1 is followed by the year where it is below. So it would be like this.
Zigzagging.
So exactly. So it would be also quite strongly regulated. why
You
the
are right.
regulation would go through both survival and recruitment. So to see what is
Yeah,
happening, you would really need the time series.
Yeah, but the thing is, what I was saying, that is like, if it's far from the carrying capacity, it's like that only some coincidental factors will just cause all birds being slightly less successful than zero or more successful. So it's not, the new recruits do not compete with the surviving individuals for the carrying capacity. That was something that I had in mind, that it's just like randomly, yeah, you would expect, if it would be far from carrying capacity, to have more points above 1. So this is quite a strong argument that this is not the case. But the thing is that if it would be just, there would be no carrying capacity for which surviving individuals and new recruits compete, you would also expect vertical lines. It would be just randomly good year, randomly bad year, and it would just manifest equally in both of these like groups.
Exactly, and I'm just saying that if you have the time series, you should
And
not
you have
be
time
able
series to visualize it or discuss.
I just for some reason didn't consider them so interesting, because you just see someone doing this, you know.
Yeah,
It would be actually interesting to make some statistical analysis of the time
exactly.
series and look at the time scale over which the density dependence is taking place, because it could be like zigzag.
Exactly.
Like it takes place exactly after one.
Negative autocorrelation or
Yeah.
positive autocorrelation. Yes,
The-
that's the
The middle period of the autocorrelation or something, or it could go slower, like it could go like high capacity and then separately
yeah,
down,
exactly.
like that. So that there can be different time scales when the regulation takes place.
Yeah, oscillating dynamics caused by,
Yeah.
for example, I don't know, like non-seasonal sources of I don't know, some resources for the species. Interesting.
Yeah. It could be also seasonal, but.
Yeah, exactly. Okay, yeah.
So here we have like the two scenarios of this gradient, where we look at the correlation of survival and recruitment from the negative to positive, and the different. It shows the different ways the population is regulated. Yeah, here I wanted just to show that in the species, in this report bird, survival was density dependent and recruitment was density dependent, but in graded only the recruitment was density dependent.
Are the warblers by any chance something like cooperative breeders, or do they rely on helpers? They don't. Okay.
No.
Okay.
So we were also interested in a different gradient, and that's saying how much of variance of the population growth is explained by survival and how much by recruitment. So I have invented this statistics, which is the higher value, the values higher than 0.5 means that it's more affected by survival, and the values lower than this means it's more affected by recruitment. And like the same limits are 0 and 1, but it can also go below these, like beyond these values, because of this covariance.
So it's like correlation, but you divide it by only variance of one parameter. Because correlation, yes, okay. And it doesn't have a kind of nice name. This is strange.
No, this is my invention, because because the variance of this one is, I had the formula, but I cannot.
Oh, I now understand, because this is total growth and this is survival. Okay, so okay.
It's not seen from the previous figure from the because the previous graphs just tell if the sum of adding up survival and recruitment is above 1 or below 1 in the vertical.
No, there's no.
In horizontal direction, it should set which.
This graph is about the correlation of the parameter of these points. But this is
But
about the variance.
the line and the horizontal line is the line where sum of these two components equals
Yes.
0, equals 1.
Yeah,
So in vertical size, it says whether the total income is above 1 or below
Yes.
1, and the horizontal
Yeah.
size tells the importance of the
of
component.
the survival.
It's a build of the cloud.
Yeah, yeah. So, yeah, but
that
that's,
should be equivalent.
no, because that is for one point. If you look at each individual point, then the left and right field is about the proportion of survival or
Yeah.
recruitment in it. But this is about the variance. This is about the variance of the parameters.
Okay.
So that's
Thank you,
different.
thank you, thank you. Sorry.
So we are looking how the population growth varies, and this is like something like regression, like more close to regression. So basically, like I want to say it the most simple way. What is most affecting the population growth? Is it survival or is it recruitment? Is it kind of? It is kind of obvious that both will affect because they are both summing to this, but which variation is
Sorry for everything. I feel lost. So you are working now. You are considering now some components, some total, some effect for the whole community, isn't it?
we are looking at the individual species at this moment, not like,
But it's seen from the previous figure, isn't it? So now we are.
So I'm trying to explain whether this population growth is
The point of the species, it would be.
this variation. Sorry,
The point of the species.
No.
the point is a year.
Is a year.
Yeah,
That's the point. Yeah.
this is one species. This is another species, and this is a year.
Sorry.
No.
So that explains. Yeah.
Yeah.
Actually, when I was looking at it, I was actually wondering that, like in population biology, I mean, like there are standardized way, like how to operate with the Leslie matrices and data structures like this, and I mean,
Yeah.
the things that you are trying to figure out from your data, it's kind of similar, like the concept of like elasticity and sensitivity of the Leslie matrices. And I was just like wondering whether you try to like think about or like figure out like what is the relationship of like these indices
Yeah.
that you are calculating with elasticity and sensitivity.
Yeah.
Because obviously like you have slightly different problem because you are exploring the variation and actually you are trying to make some estimates based on data, not based on like Leslie matrix that you know what the values are. But obviously, like at least like conceptually, there must be some links.
Yeah, there are. I was looking at it for quite some time. In this case, we don't have a full Leslie matrix because we don't have the juvenile survival. So our situation is much more simple. We have just this. And actually, the seniority is the elasticity of survival. In this case, it's very simple, so it simplifies to that the seniority is the elasticity of survival. But I didn't consider the elasticity to be important because it's also related to just one point. It's not related to the variation of the points that's creating the variation in population growth. So
the variance eliminates the effect of fluctuation, but still we can see this result from this deviation, left-right deviation. You plot a single species.
you mean in this scenario?
Yeah.
In this scenario, yeah.
Because it's equivalent to seniority.
Yeah. So sometimes it varies, like the seniority varies more and the population grows not so much, but sometimes the population growth is varying here and the seniority is almost constant.
And seniority varies along arc.
Yes.
Yeah.
This question is whether it is left or right, because
Oh, that's almost the same.
I am still thinking about yeah, I don't see much difference, but I feel from
exactly.
That's actually why I am asking about this topic.
This is not seniority is not exactly the angle, it's some trigonometric function of the angle. So there is also, but it's almost looking like it's copying the identity.
But seniority by definition is something different to whether one or other component is
Seniority is survival divided by population growth. It's just the
yeah, but it depends from dominance of one component.
Sorry?
It's different from dominance.
From this different from what?
From whether survival or recruitment is bigger or smaller. It's just implication, it's not equivalent, isn't it?
Well, I think it's
just
equivalent, because seniority is really a proportion of basically proportion of the individuals who did not recruit recently, but who kind of arrived from the past.
Yes, but keeping the same seniority, the total income decreases.
With what?
Because only if total income is constant, is one, it's on the line, not in the arc.
I'm getting lost.
Never mind. We can talk about it.
I'm also worrying to get lost the people, so to not lose the people. But
there's a difference between division and summation. It's tiny difference in this case, but it might make
okay. Let's discuss it after.
For example, some statistical bias I might expect, because there is deviation in the same direction, whether you are the symmetry transforms to asymmetry along the arc.
Let's go ahead, because
So this statistics tells us basically, like very simply said, what is more important in the variation? Is it survival or recruitment? It's like, okay, it's how much the survival is more important than recruitment.
Yeah, the point with regression is very strong here, because you would be just able to say how much of the total variance in population growth is explained by the survival. That would be it. Like, this is how I translate it for my brain, and now it makes complete sense that, like, yes.
Look at this formula. I deleted it because I thought
and it has the same explanation, basically. Only the slope would be different, whether it would be because it's in terms of total variance in this is in gamma, or
I'm really happy to look with you after at how I derived this, and maybe consult if it's good or not.
No, I think it's good.
This is also my invention. This is my invention of can look at it this Arnold.
I would say that it's basically I imagine it as regression, and now I understand it, and this will give you, I think, this measure with the variance explained by the linear model of gamma in terms of this phi or psi. What is it?
Phi,
yes. Lambda and phi. Yes, phi.
Lambda and phi are independent statistically, and the variance of phi is constant.
What about leaving this math discussion for the polar?
Yes, exactly. Sorry.
Okay, I'm happy to continue with this. So here we have another two species which are on this gradient from the one white-throat pinice hnědokřídlá, which has the most variance of recruitment, is more important in the population growth, and garden warblers, pinice slavíková, which has the most, which actually the recruitment is still more important, but out of the species that we have, the survival is most important out of the set of species. Because
there is widest spread in this direction.
Yeah.
Yes.
So these species are the small, the very fast reproducing short-lived species. So this was expected that for all of them, recruitment is more important.
Yes.
So that's it. And if we put the species into some space of into some space of these two gradients from those the first gradient from negatively correlated species to positively from negatively correlated recruitment survival, so the strong regulation to loose regulation, and the second one where from those who have where recruitment is more important to survival is more important. And we place all our species that we have and distinguish by color the migratory strategy. Then we see some interesting pattern here that most of the long distance migrants, if we, with the exceptions of these two, okay. Something. There must be something.
Yo, there is. I see it.
It's not published yet.
I have a strong paranoia. I see the pattern. There is negative relationship for blue ones. There is slightly positive for red ones, and the green ones are clustered in much smaller space than the others.
Wow.
And like this is the difference.
Yeah, but I see you see different patterns.
Yeah,
I see that these long distance migrants have more important survival than all short distance migrants.
Yes.
That's nice pattern, and that's also intuitive that the survival is important.
Long distance.
Sorry, long distance are the red ones.
Because I see pattern just for blue one.
That's the residential.
You mean
That's strongest.
I see only for the green ones.
Which pattern?
This is like crowdsourcing statistical interpretation. Just ask 1,000 people and then average their intuitions.
No, but for green ones, you can see that their survival is not that important, right? None of the green ones have high importance of survival, right?
Yeah.
Which is kind of interesting, maybe.
Maybe because they are most flexible.
Yes, exactly.
Yeah,
Yes,
because
exactly.
they can stay here or they
exactly.
can go to
Exactly.
Mediterranean
Yeah.
for winter.
Yes.
Yeah, that's perhaps interesting. I was also trying to make the pařátový graph, the talent plot for multiple species by combining the species together, but it was not showing anything interesting, or I didn't see anything interesting. But this actually is showing something, at least something. Yeah, at the beginning, this is just preliminary results. We are trying to figure out what to do next with the model. My result was to make the model. That was like a lot of work, and now we will look at this.
Now it's up the birds.
And I am now going to look into these different ways of the population regulation, because I don't recall that I saw any publication that was focused on this, and I also want to look at how transient individuals are coming into play here, because this type of regulation means that if we have low values of survival, then suddenly there is high recruitment. But if we have high levels of survival, then it's a low recruitment. But what is happening with the recruits? They have to be somewhere. They have to be buffering the population somehow. So I think this is what I'm focusing on this in the next research. So we have the new model developed, and we have under review paper, and there are two very interesting scenarios of the population regulation, and we also saw that in long distance migrants, the survival, well, in most of them is more important than in short distance migrants. So this is closing this topic. Do you have any more questions to the population dynamics?
Yes. When you assess the parameters of survival and recruitment, do you? So I don't know how your model is built. It's a Bayesian model or?
Well, it doesn't matter actually much because I am implemented in an Bayesian environment, but it will be done in maximum likelihood as well.
And do you put some covariates to assess those parameters? So in order to see which covariates could influence the recruitment and survival?
You can. Yes. I didn't.
Yeah.
I could do the same with the climate. Sorry, I could put the climate coverage, but it's possible. But I haven't done it yet.
So when you assess that, just like the parameters without any influence of any.
That was just year as a categorical covariate, so I have different survival in different years. And for transients, I was putting their year as a covariate, like so that I have the slope of the trend.
So for some data set, it's not possible to assess the transients. Like for instance, I'm thinking about the Green Dot survey where you assess actually
no, I have to capture the birds.
Yes, and
yeah, I don't know about any model that would be able to handle transients.
So how bad is it to use this data set without information on the transient to assess survival and abundance and recruitment? Is it really bad or because?
Sorry.
So how bad is it to use data set without transient information on transient to assess like survival and recruitment? Is it really bad or is it okay to do it? Or
if you have transient in the data and you don't take it into account, it can produce some strong biases in the estimates of survival. You would have basically would be underestimating survival because you would be thinking that these transient birds are just dying, which they are not. They're just disappearing. And you would have, so you would be underestimating survival and overestimating recruitment. But if you would be studying these parameters, perhaps, I don't know. So you can have serious biases. There were publications that were just measuring this bias.
okay,
It's there. And I've seen it also. I was also comparing.
okay.
And I was seeing that my model is fixing it.
Okay.
Very nice. Our model. More questions to this topic?
Species that accumulated, aggregated along the same seniority radius.
Yeah, that was this one. This is the one which was most had more constant.
You mean about the central? No.
Well, this is the most that was closer to the.
I mean, if you could see some radials, it would mean that there are clusters of species with the same seniority. Because
I've seen all the results, all the town plots of all the species, and this is the one that had most closer to one radial.
What do you mean? The pattern of radials, if you could see if.
Most of the species, this is because this is also the species that had the most data, so most precision, and most of the species were just like quite wide, spread out clouds like this one. So there was no pattern that it would be like this, but like this.
Also keep in mind that we do not have many species with this data.
Yeah.
That's also important, right? Because
we have 16 species total, and eight long distance migrants, 4 short distance migrants, and 4 residents.
Which is, by the way, quite important because we are speaking about the long distance migrants, short distance migrants. So out of 16 species, but we have 200 species in the Czech Republic, right? So it's a small sample. Of course, these are the most common and so on, but it's good to keep in mind that there are many. I was just looking on this atlas, and there are long distance migrants like bee eater, Who is like rapidly increasing, you know, so apparently there are species which are kind of very, which have very different trends from these.
Yeah, exactly.
Which is okay, but just, you know, keep in mind that we have 16 species out of 200 species breeding in the Czech Republic.
There is only 200 species breeding in the Czech Republic.
Yes.
And 400 that are like passing.
Yes,
through.
yeah.
400 also.
What?
Same number as
Land snails.
Yeah.
Are there any transient land snails that just?
And most of them are rare, so
Yes, exactly.
Wow.
So regarding the species you're using, are they all passerines? Like, do they have like a similar lifestyles or similar morphologies, etc.?
Yeah, they are the passerines.
Passerines,
They are
okay.
studying.
Because non-passerines are not caught so often.
Yeah, they
right?
need like different nets also.
Yeah.
and-
Yeah, exactly.
So they have similar life histories, more or less.
Yeah,
Okay.
yeah.
Yes, of course, the real difference, reason like diversity in life histories is somewhere out of this data set.
Did
Yeah.
you play it?
Yeah.
Actually, I was not selecting for passerines. I was selecting for all the species that have good enough data, which I put out several criteria. Many times to capture, for example, woodpeckers, but they didn't have good data.
Mhm.
So, any more questions? No. So now we're moving on to the atlas. In the atlas, we were doing with Karel Šťastný and Vladimír Vejček and Ivan Mikuláš. My work on this was mostly methodological. This one was the one that I was in charge of making. If you look at if you saw the atlas, I was in charge of making these outputs and mostly this map of probability of occurrences. And so this was most of my work, and this is called like species distribution modeling to make these maps, to make this type of maps. This is probability of occurrence, which means every place. This is the probability that if you walk for 1 hour in this pixel somewhere, this is the probability that you will meet the species, that you will hear it or see it.
One. It's like
based on very standardized data.
Oh, you must go there in spring, of course.
I disproved your theory. I didn't see this. I was there for hour. I didn't see it. So your atlas is all wrong.
This is actually, sorry, this is the same species. So if we are already talking about this is a golden oriole Jlovahai, and this is the effect of date and time of the visit. This is the probability of occurrence. So best is to go around 15 May in the 5 in the morning. Between 4 and 5 in the morning. Okay. So
I'm not free at that.
Actually, it's so difficult to get up at this time, but I think David will confirm. But when you actually make it, that you are like, wow, there are so many birds, and you are happy. I was never regretting. I was
never awake at 2 hours. I cannot confirm.
So this was my work, and this is the output, and this is the data that we're collecting in the field.
Okay.
So from this data, I made these maps. This data actually means the gray areas is where there was no data, and in the other we have this scale from white to red. The ratio of the 1 hour species list when the bird was present.
So it's something like environmental based interpolation or something like that.
Exactly. So we are making, we have to make some interpolation, and that interpolation is based on, the data and some environmental variables.
Yes.
It makes this. I will show more. So this is called species distribution modeling. This whole process is very famous and thing, but I was not happy with the methods that were already present in place and how atlases were made. So I made even better method of the models, which is not only making better predictions, but is qualitatively providing more results or more possibilities, which I will show. And one of them is that you can decompose the probability of occurrence to different components. This is what I think is the biggest advantage of this model, that it can do this decomposition. So this is very simplified explanation, but the probability of occurrence basically in this model is a sum of some environmental effect. So in this map, this is the map that shows how the probability of occurrence would look if it was if that was only the effect of the environment. And environment means habitat, so forest, meadow, field, agriculture, city, different types of environment. There is also elevation. There is also length of the rivers, length of the roads, everything, every information about the squares. And then there is the spatial effect. And the spatial effect is saying the local preference of the species, regardless of the environment. So there is the scale from red, which means the species is present less than we would expect based on the environment, and the green color is we would expect. No, the species is present more than we would expect based on environment.
By the way, are you still in golden oil?
Yeah.
Okay.
I will show this in more detail, the species in the next. And then we have the effect of date and time of the visit, which is not purpose of this atlas. We are not interested of this output is not interesting for the atlas. It's not there, but it's actually we see that it's so important when the people are going there, because in the methodology it was said like to visit 2 times per season, and from the morning up to the 12th. Actually, I tried to cut out the data that were not. People were also doing it in the afternoons, but I found out the models are better if I use all the data and just take into account this, which is also the advantage of these models, because they can model these crazy relationships that would be so difficult to model this time with some different methods. So this effect is not important for the output, but it's important to filter it out from the data, because you have data which are very messy, which are collected in different time of day and year. So it allows us to filter out the effect.
Was created this figure.
Sorry?
It was this figure. This was created using all data and just plotted. So
this is prediction. These are different predictions from the Gaussian process model. So, which one are you asking about? Just this one?
The most, yeah.
This is the prediction of probability of occurrence in the average square or over the country. So this is averaged over the whole Czech Republic in different time of day and year.
Yeah, so data were taken from all points.
Yeah, from all the sides.
From all the sides. So there is an assumption that there is what was observed.
In the data. Yeah.
Okay.
I don't know.
No, because I have some different result if you were on the just 1 or 2 point with known presence.
I would leave it.
Okay.
This is.
Yeah. So now we will look at these 2 effects and how they compose into this one for several species. I will show. So this is sorry, I don't know the English name of this. This is a crow, but no.
Hooded crow. Hooded crow.
Oh, thank you,
No.
thank you.
No,
One is carrion crow,
Uh-huh.
and the other is, I don't know.
Yeah. So you should see this is a crow. There are two species in Czech Republic, and this crow has an eastern range, also across Europe, and Czech Republic is just on the border of the continent. So you can see it's in the western part, eastern part of the Czech Republic, but it's almost not present here. But if you look at, if it would depending only on the environment, you see that the suitable environment is across the whole country.
Yo, it's hooded crow. I was
Thank
correct.
you.
This one is hooded crow, and
Yes.
the other is carrion crow.
Carrion crow, yes.
So you see, like the environment is suitable everywhere, but the species is only in this part of. So you see it also in the spatial effect that is saying the species has some aversion to Western Bohemia for some reason.
I have read a study, probably you know it as well, that it's two illusory species. There is clinal variability in all alleles, except for the alleles that are doing the gray color. Yes. So basically, they try to affiliate. They do the phenotype matching. They affiliate with self-similar individuals, and sometimes they are mixed pairs. But each hatchling is either, it looks like hooded crow, or it looks like carrion crow, so it will go and it will be affiliated with similar individuals. So all alleles are able to travel east to west and vice versa, but only the gray allele and the black allele hate each other, and they basically delineate these two crow cultures.
That's exactly the case. So that's the reason for the difference.
Exactly.
You said for some reason, but this is the reason. It is
Okay.
just the recognition, because all the genes, there is complete gene flow between these two species, except these concrete alleles for coloring the feathers. So the species identity is driven just by recognition of these colors.
It's like the national costumes or something like that.
It's because in this part of the republic it's the other crow.
Well, in Western Europe is the black one, and the Eastern.
I will tell you something that will change your life. Look, you have Europe, right? Like this is Europe. There is Siberia, and this bird is the map of the distribution, because there is this beak, there is this bird, yeah. So this is black, so there is carrion crow, and in Siberia, which is this wing, it's also black crow. So this is gray, and this is black. So the hooded crow is the map of carrion crow.
Like this? Like
Yeah, exactly. But you need to flip it so it looks more like Europe. and also turn it upside down. In my dissertation, there is one-to-one correspondence using the hooded crow as a map for crow distribution. Yes, because that's the belly. That's also like they go parallel. It's not exactly, but it's very, very similar.
I don't understand how could I miss it.
People don't have pattern recognition like I have.
Is it from your brain or is it from your AI model?
It's from my brain. That's my favorite AI model.
Thank you very much. So thank you for explanation of this pattern. I think actually these patterns are something that is very interesting for explanations, and like this is the behavior of the species with filter out effects of environments. This is something that I smell something more deeply interesting.
Well, here we know what is going on. Yeah, but in other species it is more likely. Yeah, exactly.
Yeah.
This is.
And I thank David too, because David was helping me with interpretations of these effects for the book. We have also written it there. So for golden oriole žluba hajní, we see the highest occurrences are in Moravia, and this like most close to the Pannonian part for some reason. But if you look at the environment also contains the effect of temperature and elevation. Then we have similar conditions also in Polar B, and also in some other parts. Also here in Křivoklátsko there are suitable forests, but the bird for some reason is decided that here in Polar B is not so much of the occurrence of the species, and on Křivoklátsko is almost completely missing, even though the environment is kind of good. On the other side, there are some other regions like Třeboňsko, where the probability of occurrence is much higher than would be appropriate to regarding the environment. So these patterns are also interesting, contain something that cannot be described by the environment, and that's something that may possibly contain some more information about the species distributions. Yeah.
Couldn't it in some cases be just like, the parts of the environment that you didn't have in your model?
Yeah, it could be.
Like, for instance, I don't know, like type of forests that are like, dependent on some like local like forestry.
We were looking at different classifications. Well, first we don't have forestry information like the age of the forest. We don't. But I was testing two different environmental schemes. Like one was Corim, and the other one was Quest, which has much more detailed classification of the habitat. So they have like something like Bučina, or I don't know, Lužní forest, the alluvial forest, and they have like so many different classification of meadows and everything. And so I was testing, I was comparing both, and in the end I chose the Corim because there was also the effect of that this layer is perhaps more homogeneous across the whole country, and these effects.
No, but in this case, there is no such an effect, I'm pretty sure, because I was always puzzled by it. Žluva hajný, the name says that it lives in high, which means in deciduous forests in lowlands, but you can find them in Třeboň basin, which is relatively like upland. It lives in pine forests very commonly. And then you go to Křivoklátsko, which is typical like deciduous forest, very warm, and there are no orioles at all. So it must be really something else. And nobody is surprised that it is very common in southern Moravia. But within the Czech, within Bohemia, the distribution really does not make sense ecologically, and that's an old experience of the field ornithologists. It's really there is something strange, because no one without this experience would not expect orioles living in Třeboň area in pine forests and not occurring in some nice lowland forests.
So they do live in the pine forests, really.
Yes.
Because yes. I mean, if you show me like the map of Bohemia from above, I mean, like I would just say that it's like a map of occurrence of like lowland pine forests, right?
No.
Like for Bohemia, it's pretty much like that. Like it's eastern Bohemia, and then Třeboňsko, and then.
Yeah, there are lots of pines everywhere. That's Králové and Pardubice.
Yes, but they are mostly associated with the broadleaf forest.
Yes.
Yeah. Here, but if you have old forest from here, it's not there. So, yeah.
By the way, I was really puzzled by this, and I was thinking that maybe this is typical long distance migrant, really long distance migrant. So maybe 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 there are some local populations
Yeah.
who migrate to different places, and it has something to do with their because connectivity and the philopatry and these
And it
things.
takes a lot of times before they discover these new suitable
Exactly.
locations.
Yeah. So the long distance migrants are maybe less flexible in colonizing
Exactly.
appropriate habitats. Also, I said it's not intuitive because they cross such long distances, but also they have much less time here. They arrive, they breed, and they leave. So they don't have that.
Yeah, they arrive only in May and they leave in the end of June, basically.
It would be very interesting for comparison to see like which cities in Croatia in summer are occupied by Czechs. I think there will be like perfectly good resorts where there are zero Czechs because they don't know them and they don't explore. They just go where they were going when they were.
This is a beautiful like cross
domain analogy.
Only 5 minutes.
Yeah.
Oh my God, almost 12.
You have to start speaking about the lunch.
I don't know, so I will not show this one probably. We have some interesting patterns in the date and time, but that's just to show the possibilities. These models can actually do the trimodal distributions like that. You cannot get it from some quadratic models that are used. And so my contribution in this was this Gaussian process, this novel method that allows for these complicated distributions, complicated relationships. It has the advantages of the other methods like random forest, which were used in previous atlases, which can handle a large amount of correlated variables and non-linear relationships and interactions of arbitrary degree. But these previous older methods, they do not allow this beautiful decomposition, like in the pure sense. You have to use some dirty workarounds to achieve something like this. So these models can very nicely define all these effects, and you can make predictions for these effects. And also the models, these Gaussian process models have better predictions. So it's not only quantitatively better than previous methods, but also qualitatively brings something new that opens new possibilities for research. Here just demonstration how this is the true surface when we have a relationship of two variables that is like 3D. So this is the true surface, and then this is how would it be approximated by a random forest. And the Gaussian process model you see has better predictions. It can do these crazy relationships, and also just my preliminary test shows that if you look at the quality of the model from Gaussian process and from random forest, like all of them were better. So that's. But I didn't handle a spatial effect because it's not possible to do it directly. So this is just preliminary. So I thank to Jiří Reif and David Štor for cooperation on this, and many other people and institutions. Yeah. Do we have time for more questions? I'm sorry, I didn't notice how.
No, there were plenty of questions during the talk, so I think we understand everything.
So shall I introduce the lunch?
Yeah.
This is actually something. This is Major Cafe just close to the National Theatre, and it has this only place in Prague which has a raw food in Czech živá strava.
Yeah. Only raw food.
Yeah, okay. Only raw food. And this has changed my life. I'm like eating 95% of my food is this, and it completely changed. I'm much more healthier.
So what is it? This
is food that didn't come through temperature higher than 42 degrees. So it contains if I put my food into ground, it will grow. It's full of life, It's not killed by high temperatures.
So there is no meat at all.
No, but it's
No, only raw meat. Only. Steak with fresh carrots.
Giraffe is a bit confusing.
This is vegan. So
Vegan and also not cooked. It's one step.
No, but okay, you can have,
backwards.
okay, I didn't know that this is vegan because you can have fish which is not cooked.
Exactly, sushi.
So yeah. So that would be raw food for me.
yeah.
But it's not alive, right? Because in plant every cell can live alone. So when you have raw, it's still alive. But when you have meat, it's dying and it's decomposing and it's disgusting.
It depends on the animal. If you take, for example, porifera.
Okay, so maybe
So
porifera avocado toast.
and one of the most benefits of this food is that you have entirety through the day. I'm a little bit tired after I eat food, but after this I can work all day and I'm kind of like.
Okay.
So enjoy the feeling of vitality after the lunch.
I look very much forward to that.